Welcome back in LINQ Advanced tutorial. This section will see advanced concept. So the question is, how do you implement a link query to perform self-join in a single table? So let's uncomment this area. Let's see self-join in working condition. So what we are doing, we have a one class person61 and that have ID and name, and these are the property of this. We are assigning some data, and over here we are doing from P1 in persons and join P2 in persons on PD ID to parent ID. This one. So we are self joining with ID to parent ID. Let's run this and see the output. So it will print like a name. If we go to here, if we go to here, you can see Zon, Zen. Let's move to the our data set so we can have close look. Zon and this person ID is 0. So Zon, Zen, because the Zen have a person ID as a top. So John, Zen and John, Tom. So this John have two person ID and Jane have second. So this one. So Jane have Emily and Mike and so on. So this is joining with the self joining with the same single table. So let's see. Let's comment this and let's jump to the next question. So our next question is how do you implement a link query that performs recursive travels? So if you go to the traverse tree, you can see this is a recursive. So we are getting a children select many by using select many and passing this traverse tree inside of again child, and this is expecting node 62 node type, and then again value concatenating that children and again passing back. So this traversing with, we are adding a value 1, 2, 3, 4, 5 like so on, and grandchildren, children is 2, 3 and grandchildren is 4, 5, 6. So we need to traverse by 1, 2 and then 3, 4, 5, whatever the path is. Now let's see the result. So if we go to our data set, which is here, so here you can see parents is 1, then 2, and child 1, we are adding child 1 and child 2. So 2 and 3. So first we move to the 2. Now child 1 have grandchild 1, that is 4. So 2 have a 4, then it's 2 is grandchild 1 is punished. Now grandchild 2, child 2 have a 2 grandchild, that is 5 and 6. So 3 and then 5 and 6. So 1, 2, 4, 1, 2, 4 and 3, 5, 6. 1, 2, 4 and 3, 5, 6 like that. So traversing is by using our recursive method. So this is the example of recursion. Now let's move to the next question. How do you implement link query that performs sliding window aggregation? Sliding window. So let's see a sliding window example. We have data point. We have declared a data point which have a value like 1, 2, 3, 4, 5 in a date and value as a 10, 15. These are the value. So let's see how we achieve sliding window by use of escape and take. So let's run this. We have a window size 3. So it will print like 30, 40 in a, let's see this. So we have something like this window 010122 to 3123, that is aggregate value 45, 20, 30, 45. Now we have second to fourth because we have a sliding window 3. So first we will take these 3, then second to 4, then third to 5, then 4 to 6, and so on. So this is sliding window. Sliding window. Over here we had given like index, whatever the index is, sliding window size, we will take that much, that is 3, and we are indexing, skipping previous value till the index. Suppose first time it will be 0, then we will skip this first record, then second, then third, and so on. So let's move to the next question. I believe it is clear for you. If it is not, do it for yourself and then it will be clear to you. So by using skip and take, we perform sliding window operation. Now move to the next question. How do you implement LINQ query that perform complex graph travels? Previously we have done travels in a tree. Now we have a complex graph travels. Now let's uncomment this section. See here, we have a node A, B, C, D, E, and then we are adding a is to that node, outgoing node, and that node is like that node A, node B, node C, node D, and tree targeted node is this, source node is this, and weight is 1, 3, whatever. And we are calculating shortest path by using DJ Castra algorithm. So we and return the shortest path between two nodes. So we have to return a shortest path between two nodes like C and E, which will be the shortest path that will be returned from this section by using DJ Castra algorithm. So let's see this implement function also. So this is nothing. This is implementation of DJ Katra, and universal node count is greater than 0. Then order by, if node current node is in node, then we are breaking the loop. If it is containing, then we are continuing. If it is not, then we are assigning neighborhood and neighbor node. And then at the last we do path reverse and returning our path. That is. So let's run this command. So the shortest path from E to A to E, A to E is go to A to B, then D, then E. So you can see the C here is omitted. So why? If you see the data, node A, node B targeted source weight is 1, and then node C, node B, node C. If you see in a graphical corner, then A, we will traverse from A to B, then D to E. This is the shortest path between A to E to reach from A to E. Let's comment this. You can see by using your yourself, and you can have, if you have a question, let me know. I will try to explain that. How do you implement LINQ query that efficiently handle pagination on a large data set without loading all record into a memory? Let's simulate some data. We have innumerable range. We are doing like 1, 10, 100. So this much data we are storing into our data. So page size is 10 and page number, we are on page number 3. So this can be dynamic as per your requirement. So page size you can set, page number you can set. I am here just taking that much data from this data. So by using skip and take is useful to get any loading when you have like 21, 22, 23. This third page we are extracting. So 0 to 1, 0 to 1, we are extracting third page. Record to skip. Record to skip is page number -1 into page size. So 10, 20 record we had skipped. 0 to 10, 1 page, 10 to 20, second page, and 21 to 30, our third page. So this is the way you can achieve your pagination by the use of page size, page number, and that is skip and take. So by the use of skip and take, you can achieve your pagination in your website. Now let's move to the next question, 66. How to implement link query that combine data from multiple data sources, such as relational database and web service, into a single result set. Simulate data source, a list of customer from a database and list of order from a web service. So let's see this example. We have this customer, get customer from get data, get order from web service. These two examples we have. And in a query, we are defining this. So if you go to this function, what we have, we are adding some, in a real life, you can have data, your database, which is returning the data. Here I'm just using a class method and have a 1, 2, 3 data. And then you have next one, get order from the web service. So web service is returning, suppose say, orders this like order number, total amount, and these. So let's move to the next section. Over here, what we are doing from the customers, this one, join order from the customer ID to customer ID. And we are joining these two data into one data set, and over here we are iterating that data set. So let's see. You can have your if you are using your database, then you can have your database path and all those things. So if you see here, you can have this customer zone, order number ORD1, amount is 100. So if you go to the data, so from the database, we have only name 1, 2, 3 zone, and then if you see here, so customer ID 1, that is zone, have 100 and 150 two order. So this is 100 and 150 two order, and then customer ID 2, then have one order, that is total amount of 200. So it's 200. We can achieve like that. So let's move to the next section. Next question. Let's move to the next question, question number 67. How do you implement link query that dynamically generate the query expression based on user input or runtime condition? Okay. So we have to generate a link queue according to our condition, and that will be a dynamic. So let's see what we have. We have a product. These have a 4 record, and in a product name, a dynamically filter condition based on the user input after runtime. Some filter, sample filter, I'm just passing a sample filter. You can pass in your query, in your function. You can define these things in a function. You can pass a product name and max price, or whatever the criteria you have, you can pass here. So these two conditions, constructing a dynamic periodic expression, these are the condition which building a dynamic query, build predict. So here, if you see the expression func type, that is getting a product and then boolean. If you have equal operation, then less than or equal, and also and then lambda equation that is returning. So we are doing on the basis of name and price. So we are building this build predict operation, and then we are as curable filtering product using dynamic predicted expression. So as curable and then to list, iterating by to list, and then we are printing this data. So let's see by run. These are the advanced concepts which need more focus. So I'm just giving you a brief idea. I'm giving you a code of that question. You can have look. You need to have one by one look for this to get a more idea. So product ID 1, name is product A, category A, and price is 10.5. So maximum price 15. So which have maximum price 15? We are getting only those records which have maximum price 15. So this price is 15.75. So it's not fitting. 20, it's not 10.5 we can have. That is product A, and the product name is product A. So we are filtering data according to the our sample filter condition. You can have in a function, you can pass this as a parameter, and then you can do this as per your requirement. So let's see, jump to the next question. Question number 68. This one, let's uncomment this. Let's read the question first. How do you implement LINQ query that perform fuzzy matching or similarity search on textual data? So this one like APPL, we want to search in this list. So how you can compute length distance. So go to here, and you can see how the function is implemented, the source length, target length, and the last we are returning the distance. So we are finding the distance of, that is distance of given character. So we match using LINQ query, and that will, this function is return our shortest path, you can say, or a distance. So that distance will be written, and then we are iterating that, and we do a right line. So let's see, by using this, what will be the output. Let's see console. You can see the apple is came. We have a pineapple also, APPL, but the highest preference given to the word which is started with this. So pineapple is ignored, and apple is came here because the compute length in distance gives this one. So if you go to this is taking search term apple, and this one is your string. You can do this, you can debug this and see what is your result. Now let's comment this. Let's move to the next question. Now this one, let's uncomment this section and then read the question. So the question is, how do you implement LINQ query that handle temporal data and perform interval based operation, such as finding overlapping time period, temporal based operation and overlapping time period. So start date is 1/20/11 and end date is 28. This one have a start date third month 1/31. This one has a start date 15. So this and this time period is overlapping. It's ending at 28. It's starting at 15, and so on. So we'll see, select the overlapping time period. How we will select the overlapping time period? Let's run this and see. So we have overlapping time period is 1122 to 2822. See this one, 1122 to 28 to 22, because this one is overlap with this time period. So start date is less than other date, end date is greater than equal to this. So this one is overlap with this time period. You can have by using time period, by using LINQ. So let's comment this area. Let's move to the next section. Question number 70. How do you implement LINQ query that perform advanced statistical analysis, such as regression analysis or clustering on the data set? So for this, we need to include our mathnet.numeric NuGet package. This mathnet. For that, we need to include our NuGet package to calculate, to perform mathematical calculation. So now let's see what we are doing. We are adding a data point. We are selecting a data point and then converting into array. Then we are fitting into a line. We are over here perform linear regression using math.len. So this x extract x and y value into a separate array. We are extracting x value and y value in separate array. Then we are performing linear regression using math.numeric. So fit.line will fit your data into a linear regression, fit your model. Now your model is ready, regression. So retrieve the regression coefficient. Now you need to have a coefficient, slope and intercept. So regression equation y equal to slope into x into that is intercept. Now calculate the periodic y value for the new x value. So suppose say our new x is 6, then what will be the y? So new x is still 5. We are giving a training data set. Now we are testing our data. Now we are testing our model. So let's see. So this is regression method. Let's see. So as per training data, if x is 1, y is 2. If x is 2, y is 3. If x is 3, y is 4. X is 4, y is 5. X is 5, y is 6. So it has some relation like plus 1. So here you can say predict if the x is 6, then y is 7. So this is your regression, and you will have a model data set, model ready. You can use your data set, training data set over here. You are fitting your data into a regression. Then you are finding a slope. Then you put into a regression equation. Then you find your prediction. This is ML part. This is just an extra advanced part. So now move to the 71 question. Again, we need a Kafka for this. We had already have a NuGet practice Kafka. So how do you implement LINQ query that perform real-time string processing on continuously arriving data? So this is something which you need to have you need to perform a real data stream processing. You need to perform real data set, and this function is doing like this one, process data. So if you go to the process data, your input is, we are just converting, perform string processing using LINQ or other method. So we are just converting to uppercase, or we are nothing doing fancy more. And here we have a bootstrap server. So server location, then your group ID and auto reset. These are the function. Let's see. This is a NuGet function. So this have I consumer list which consuming your consumer. So process data set. Here, because of this, we have a local host. So it might not give you a exact result. So if you have a bootstrap server, you can give the server name over there. So here, if you run this, you might have, yeah, say localhost bootstrap connect to invalid IP port. So it is trying to connect, but it cannot connect because of the wrong address. So let's comment this. You can achieve like this. I am giving you a frame only. You can, based on this frame, you can do research. So how do you implement link query that perform efficient spatial queries such as finding nearby location and calculating distance? So by using this NuGet package net topology suite, this is basically finding a nearby location. So we need to find a coordinate which is nearby. Like say point is 10, 20, 15, 25, 30, 35. Now we are finding 12 and 22. 12 and 22 new point. We have a 4 point already. Now we are trying to find this position which is nearby coordinate A, B or C or D. So in a distance, if you see in a distance, coordinate distance, this is a function like this is returning geometric function. This returns distance from the coordinate of S. So less than 10, then we are selecting name and we are plotting the nearby condition. So 10 to 12 nearby point is, our nearby point is, if you see the location A and B is nearby. So if you go to our there, our code A and B, so 10, 20 and 15, 25, it lies here. So nearby point is A and B, C and D is 5. Now let's comment this. This is finding nearby point on our graph. So let's move to the next section, question number 73. Now, how do you implement link query that perform advanced data analytics such as time series analytics, outlier detection, and pattern recognition? So now you have outlier detection, pattern recognition. This is time series forecasting. So in this section, what we are doing, we have a data, just a sample data set. This is, so this time series 10, 20, 9, 5, this is, and we are calculating the mean and standard deviation of this time series, and we are finding outlier where this standard deviation, this value minus mean is greater than 2 into standard deviation. So output of the outlier, which is with outlier is basically this. These are the time series from one set, but this 50, it's look like some wrong in. So how you will find which one is outlier? So let's see. If you see here, the output is outlier is 15. So you can by watch also, by observation also, you can see these data are little, it's it's in a same area, but 50 is more ahead. So this is the outlier. So how to find outlier, perform time series, you can use like this. Now let's move to the next question. These are ML question, machine learning question. So you need to know which is outlier, what is standard deviation, what is mean, what is mode, these things you need to know. Now, how do we implement link query that handle large scale distributed data processing using technology like Apache Spark or Hadoop? Hadoop. So for this Hadoop or Spark, we need a NuGet package Spark. We are doing from the Spark. We are doing through the Spark. So let's uncomment this and let's see what is. Over here, we need to have data processing, example like Spark session, and then we need to provide the path, our file, which file we are going to proceed, then column name, what column we are going to filter, then which column we are going to group by, and then aggregate data we are going to show. This one doesn't have actual file and this, so it will not give you the result, actual result. You can have replace your own file along with this. So see here the number of GVM back, you see million is a static. These are using port, this error because of the this is we do not have app name and this. So you create your Spark session, and then this just the example which I am going to show you how to read the CSV file and then how to filter that, then how to filter that. So this is the example. Now let's move to the 75 question number, that is ML new prediction model. So let's move to the 76 number. How do you implement LINQ query that handle multi-language or internationalization scenarios such as sorting and filtering localized data? So we are going to filter localized data. Let's see first uncomment this. So here if you see this is apple, banana, but this is the special language like FFL. A have a dot, two dot at top, A C have a caret, and these are. So set the desired culture of sorting and filtering. So we are sorting on according to the French, German culture. Sorry, according to the German. These two are written in a German. So we setting our culture info as a German. Now order by to our culture, and then start with A. We are filtering that data. So let's see the result. You can have you can extract your localized data. So this is C. The sorted product is apple, okay, banana, and this, and the filter product is localized product is apple. Maybe I pronounced wrong, but I'm sorry. In a German, apple is known as a apple. Maybe something wrong in my German. Okay, let's move to the question number 77. How do you implement LINQ query that handle graph-based data structures such as social, network, and recommendation system? It's a recommendation system which you are going to recommend, like in a Facebook you have you are recommending some brand, or you are recommending some dishes like that. So how you will recommend, like user have these are the graph. Inside of this graph we have a user. Let's have this like, and this our relation. So it's look little nice. So this structure have alias Bob and Charlie, and suggested user 1, target user 2, and friend. So let's see in an example, then you can get friend is the function which is doing all. So we'll see what is inside of the get friend function. So friend user Alice, friend is Bob. So let's see our code. So user Alice, friend is Bob. So suggested user 1, target user 2, friend. ID suggested user 1, target user 2, 2 have a 3. So 2 and 3, that is friend. So common is a Bob. So friends is Bob. Alice is a friend of Bob, and Bob is also a friend of Charlie. So Bob is a common friend. So this is trending like get friend. So this one, you can see this graph dot get friend. So this have nothing. We have user ID and type is friend. Then we are selecting that and returning back to the friend. this method is performing graph operation. Example method get friend to the user. So this is just a simple method which we are. Okay. Now let's move to the next part. Next question. Question number 78. How do you implement link query that integrates with a specialized database or data store, such as graph database or time series database? So for this we need Neo4j or Neo4j client, NuGet package. I'm just giving you a code you can use because of the I do not have this influx DB. So when you have influx DB and all, you can have this. You can have this. So you can have this. You can use this influx and get whatever the result you can get as a query and select a star from temperature. You can pass SQL query into that into as a parameter and you will get this. So for this you need this Neo4j. This is the code you can use. Let's implement this. Now let's move to the question number 79. How do you implement link query that perform advanced data transformation such as pivoting, unpivoting, and reshaping data for analysis or reporting? So just column to row, row to column, and so on. We are doing here, we are preparing our data set, data for report purpose. So we have these data category one, this item has sorting this, we are pivot this category and calculate the sum of average, then each category, then we are pivoting data, now unpivot, we are doing here unpivot data, this by using reshape item, this value and other. Let's see this. You see the example, then you will understand clearly. So, if you see, we go to the data set. So, we have pivoted data category 1, sum value 15, average value 7.5. Category 1 have 10 and 5, 15. So sum value is 15 and average is 7.5. Category 2 is sum value 27. 27 is 15 plus 12, 27. Now we are providing data. Category 1 property value is 10. Okay. Category 1 property other value is 20. 2 property value 15 and other value 25. And now we added this below also this property value, other value is 18. And this other value category 2, see, property value is 12 and this 5. So 5 and 15 is there, but 12 is coming from where? From, yes. Other item value, other item, we are reshaping our system. So we introduce new item there. That is the output of this program. You can debug this one line by line because of the time constraint. You can debug this line by line and then you can see the result. Okay. You can debug this line by line. So see, line by line you can. So you can debug this line by line and see the result. Okay. Now let's close this. Now move to the question number 80. How do you implement link query that handle complex event processing such as detecting pattern or correlation into a event stream? Correlation. This correlation is basically what we have a ML part. So detecting a pattern, get event stream. This function is getting an event. This is defined over here. So nothing. We are just introducing event, that is ABCG, and adding a time and second more than current time second one. So add time and date. Now we have event 1, event 2, event 3. And now this event type A, B, and C, and event time span is less than event time 2. And then we are selecting this and then pattern detected. What will be the pattern? You can see here. See, 1, 2, 3, 1, 2, 6, 1, 5, 6, 4, 5, 6. So pattern detected is 1, 2, 3. First one is event 1, 1, 2, 3. If you go to the data, then you can understand that clearly. So 1, 2, 3, 1, 2, 3, ABC, then ABC, 1, 2, 6, 1, 2, 6, ABC, ABC, then this AB and this C, then this AB, like so, 1, 2, 6, 1, 5, 6, 1, 5, A, B, and C, then 1, 4, 6, 1, A, and then 4, 4, 5, 6, 4, 5, 6 is this one, A, B, C. So this is the pattern we can have detected. This is like ABC, these two, take this AB and this. So 1 to 6. Now take this A and this BC. So another pattern. Now take this ABC. That is another pattern. So this is till now. We have 20 more questions, which is more expert level from 81 to 100, which we will I will give you in another video. Till now, bye. Please subscribe the channel.